Okay, so the last topic in population ecology is we're gonna chat for a minute about something called an age structure diagram, and then we're gonna talk about human population growth specifically. So, if you haven't figured it out already, one thing that I find incredibly funny, I don't know, maybe that's not the word, amusing, maybe, I don't know, is a lot of people have this idea of ecologists as being like a bunch of hippies that, wear hemp and Birkenstocks and, hang out in the forest and hug trees and stuff, which is true. No, which can be true. But also, ecology has a lot of math in it, right? A lot more math than a lot of other areas of biology, which is actually kind of interesting. Yeah, so anyway, tons of graphs, tons of mathematical models, tons of just so much math. And here's another graph, right? So let's talk about what an age structure diagram is, and let's talk about why they are important. Now, you could construct an age structure diagram for any type of organism, animal, plant, fungus, whoever, right? All of the examples that we're going to deal with are for humans, okay? But you could use them for any population, okay? Fundamentally, the purpose of an age structure diagram is it tells you the makeup of a population, once again, based on like age intervals, okay? Why is it useful? The reason that it's useful is that age structure diagrams can help you see the future. Seriously, right? Like age structure diagrams can actually help you see if a population is increasing. Is it increasing rapidly? Is it increasing slowly? Is the population size going to stay about the same? Is the population shrinking? Right? So age structure diagrams can tell you all of that, and I will explain to you how next. Okay, so first let's just figure out the anatomy of an age structure diagram, and then we will look at how they can tell the future. Okay, so there's different ways of doing it. This is just one type. Okay, essentially what we're looking at here. So let's look at the one that says United States 2010. Okay, so what they've done here is they've put females on one side and they've put males on the other side. Okay, and they've used census data, right? So how many women are in the US? How many men are in the US? And what are their ages, right? So how many females between the age of 0 and 4 are there? How many females are there between 5 and 9? How many, so on and so forth. Okay, same thing for males, right? So that's what the bars mean. Okay, now the other thing that they've done to just sort of help you see what you're looking at here is they have taken some colors to represent, where you are in your breeding capacity. Okay, so between the ages of 0 and 14, you are not yet able to produce offspring. So you are pre-childbearing. Okay, between the ages of 15 to 45 is when most people have kids. So those are your peak childbearing age, right? And then after 45, right? Typically it's after childbearing age, right? Now, it's true that men can father a child once they hit puberty, right? So not if they are prepubescent, but after puberty, men can father a child at any age, but women can't after menopause, okay? The other thing though is that men, their sperm quality and sperm numbers decline over age, as they get older too. So it makes, it's still less likely even if it's possible, okay? Anyway, all right, so you understand what's in the graph, right? So how wide the bar is tells you how many, right? So there's over 9 million in at least 10 years ago. There were over 9 million girls That's probably about 10. There were about 10 million girls in the US between the ages of 0 and 4. So baby girls, little girls. Okay? That's how you read this. All right. Over here, we have a different country that we can look at their age structure. Okay? So it's set up the same way, but you'll notice the shape is very different of the age structure diagram, right? So the US is like a fat, curvy column kind of shape. It gets narrow at the top, but it's kind of, yeah? Whereas Ethiopia is like a pyramid, right? It's real wide at the bottom and real skinny at the top, okay? So one other thing I'll point out that's kind of interesting is on each of these, they've calculated and they're showing you the average age. So if you took the age of all Americans, every American that was alive in 2010, right? At least everyone that was in the census. I'm assuming they used the census for this, right? The average age, if you add everybody up together, is 38, okay? The average age in Ethiopia is 17, right? So a much greater proportion of their population are young. There are very few Ethiopians, right, that are older. So see how skinny the pyramid is up here relative to the base of the pyramid? This base isn't quite as wide as the US because their population overall is smaller, right? But look at how much it differs, you know, towards the top of the structure, okay? So there's what that means is that these two populations have a very different makeup, right? We have a lot of people of, you know, kind of evenly distributed, more or less, over all of the age groups until we're getting up, you know, into, you know, it's sort of the 70s and then it starts to go down a little bit. But even still, we got lots of people representing in the 80s, okay? Whereas in Ethiopia, the vast majority of their population are under the age of 15, right? And even their younger adults, right, there's many fewer at each age group than there are of the young ones, right, the kids. And then, you know, over middle age and up, right, it's even fewer. Okay, so the makeup of their population is very different in Ethiopia compared to the US. Okay, so how does this predict growth? How do we use this to tell the future? Okay, so now we're looking at a different country, right? Now we're looking at Mexico. Okay, and so what we're looking at here is we're looking at actual data from 1990 and we're looking at actual data from 2015, and then this is projected based on this previous information. Okay, so the important thing to remember, right, is that as time passes, people move up the diagram, right? So this block of women, females, girls, right, from 0 to 14, all of the girls from 0 to 14 in 1990, when it was 2015, they were now, guess what? Between the ages of 25 and, wait, can I read? Yes, 25 and 40, because it's 25 years later. Yeah? So after 25 years, right, these bands move up. Okay? All right. So what that means is that there's a lot of people now in the reproductive years than there were back here, right? So back here, there were only, you know, this many, right? So back in 1990, there were a smaller, each band, each, you know, bar essentially in the prime reproductive years were smaller than they were in 2015, right? In 2015, all of these bars are wider. Why are they wider? Well, we knew they were going to be wider because these people, after 25 years passed, grew up, because that's what you do, right? Yeah. And so it's really wide here now. Interesting. Okay. So now what's going to happen? All right. So projected going forward, basically what we're doing is we're just scooting everybody up another 25 years. Right? So now this block of people is going to get bumped up to here. Right? And, you know, some of them are going to die. So bar gets a little narrower. Right? And now these guys are going to get bumped up here. Girls, I should say. Right? Are going to move up here because that's what happens when you age. Right? And so when you have a lot of width, when you have wide bars in the pre-reproductive stage, what that means is that the population is going to get bigger in the future, because at that present moment, these people are in the green bars, so they're not making babies yet. But by the time they're up here, they are making babies. So these bars are going to get wider, which means these bars are going to get wider, right? And then when, you know, another 25 years later, right, that's still going to be wide. Yeah. So we can predict population growth by looking at like the proportions of how wide the bars are in the different age groupings. Okay. So let's go back to the US and Ethiopia for a minute. Okay. So what does this tell you about the capacity for the US population to go up, and also the population in Ethiopia? I'll let you think that. All right, well, given how wide these bars are down here at the bottom, right? Let's say it's 25 years later. Now we've got bars like that in that location. So there's more population overall. Yeah. And then another 25 years after that, wider overall. Okay. So Ethiopia, if we look at this diagram, is currently in a phase, right, in a stage where they're experiencing rapid population growth in the future, right? They're in a period of rapid population growth. What about the US? Is it wider at the base? Is it wider in the middle? We're kind of steady, right? So there's population growth is happening, but it's small. What's the deal with this? Why is there such a big hump here? What's that about? Anybody like to insult the senior citizens of today by saying, okay, boomer? Yeah. So why is that generation called the baby boomers? Right? So people came back from war, right? And what do you do when you come back from war? Start a family. Right? And so all of, you know, that generation, my parents' generation, right? They're baby boomers. There were a whole bunch of babies born in a short period of time in that generation, right? Because after the war, everybody's, you know, more prosperous and family of kids and everything's wonderful, right? So that bump is the baby boomer, right? And that led to a lot of population growth, actually, not just during that time, but if there's more baby boomers, then there's going to be more Gen Xers. And if there's more Gen Xers, there's going to be more millennials. And if there's more you see where I'm going with this? Yeah? There's going to be more Gen Z. I think that's what we're calling them now. I don't know. I just call them obnoxious because they're my children. Anyway, you get the idea. By the way, I'm right on the cusp between Gen X and millennial. I'm a cusper. And I've heard several of my friends, people, you know, in my little micro generation, refer to ourselves as the Oregon Trail generation. And if you don't know what I'm talking about, it's because you're not cool like us. And you should look it up. Okay, so I am in the Oregon Trail generation. Okay, so that's how you predict. All right, so here's that baby boomer situation, right? So the baby boom was right here, right? So lots of babies born in the late 40s, early 50s. Yeah. My mom, technically, I don't know, maybe they're not even quite, they're like early boomers, my parents. When was my mom born? Oh, no. My mom was born in 58. My dad, or 48. My dad was born in 50. Yeah, they're baby boomers. They're right in there, right? So you have this bulge. Yeah. And then you still have the bulge. So the children born between there and there, right? You still have the bulge. And you see another like micro bulge here. That's because they were born when these guys started having babies. Right? So you have the baby boomer bulge, and then you have another bulge. I'm right. Right? You have another bulge there. Yeah. Those are millennials, really. Okay. You have another bulge there, right? Um, because there were so many people in this age group. Yeah. And now, in the going forward, it'll kind of smooth out as our baby boomers start to, our baby boomers are all dead, in 2033 are going to be up there. Right? So it'll kind of smooth out, right? But that's how populations grow. Okay, you can kind of track it and predict. All right, we'll come back to demographic transition in 1 second, but real fast, let's look at this. Okay, this I like because now we're comparing a few other things. Okay, so 2 of these look familiar, and this is from a different book, and it's from a different year, and it's slightly different, but the idea is the same. Okay, so right, the blue bar with the yellow boxes in it represents the primary reproductive age. Okay. All right. So based on the shape of the pyramid, what kind of population growth are we expecting to see in Kenya? Rapid growth, slow growth, no growth, population shrinking. What are we expecting to happen in Kenya based on this diagram? That's right. Rapid growth. Okay, and what did we say about the US? We already kind of talked. There's that baby boom again, right? There's the hump. So you can tell this is old data because it's saying that the baby boomers, are that age. This is really old data. Whatever, that doesn't matter. Okay, so the US at this time, it's still a pyramid, right? It's still a triangle in the sense that the base, is wider than the top. Yeah, so this would represent slow growth. So the population is growing, but it's not growing very fast. Okay, what's happening in Italy? Well, the top is always narrow just because, people die when they get old, right? So the top is always narrow, but look at what's happening like here. Do you see how it's kind of fat in the middle but narrow at the bottom? What do you think is happening there? What do you think is going to happen in the future from this when this diagram was made? The population is shrinking, okay? Which is actually good overall because human population growth is out of control. We're going to look at that next. It's great overall, but it has its problems, right? So specifically economically, it has all kinds of problems. So what do you do if the vast majority of your population is retired? What does that do to your gross, profit as a country, right? What do you do if the majority of your population is getting Social Security or benefits because they're retired, right? So the baby boomers are getting ready to retire, y'all, or they are retired. My parents are both retired, right? So how does it affect our economy when a large portion of our population is retired? It's a little tricky. So, I'll let you talk to your economics professor about that in detail. But the idea is that it's actually kind of problematic if your population is shrinking, right? Because then there's going to be fewer people working to support the older people that are retired. right? And so in places where this is happening, in places like Italy and other European countries, and Japan is another place where this is happening, is the government is actually it actually pays people to have kids. They're actually like, please, please, please have kids. We'll pay you. We'll just pay you $3,000 to have a baby, right? And we'll give you free childcare, and we'll do whatever, right? Because of the economic trickiness of having too few young folks, right? It's not a big deal when they're little, but it's when they, are adults and the economy is based on the number of them. If we've got a top heavy pyramid like this, it's problematic. Anyway, okay. So that's how you use these to figure stuff out, okay? Let's talk about demographic transition, and then we'll talk about human population growth. So demographic transition is this really interesting phenomenon that has happened and is still happening with human populations. This is really human focused, this section, okay? So for much of human history, we had very slow population growth because birth rates were high, right? People had lots of babies, right? There were large families. But along with that, death rates were also high, right? So, 200 years ago, 100 years ago, you lived on a farm and you had, 8 kids, not all of them are going to make it to adulthood, right? Because antibiotics didn't exist yet, right? There was a lot more disease. It was bad. Okay. So birth rates were higher, but so were death rates. So what that means is that the population wasn't growing very fast. Okay. All right. So then industrial revolution comes along, right? We get better sanitation, so cleaner water. We have the industrial revolution, which makes industry better and faster and more productive, right? We're better at shipping food around all over the place, right? There are major technological advances in medicine, antibiotics, things like that, right? So death rates go way down, right? So look what happened to the death rates, pew, which is awesome, right? Not as many people dying, okay? But part of the problem with that is if birth rates remain high, what happens to the overall population growth? Well, if there's a big gap between birth rates and death rates, that means you have really fast population growth. Okay? All right. Well, eventually, birth rates kind of catch up with growth rates. Eventually, birth rates go down. And the reason that they go down is as awful and, cavalier as this sounds, right? If you have 10 kids, but 5 of them don't make it, right? You can survive to have, you can afford to have 5 kids. But if you have 10 kids and all 10 of them survive, you can't afford to have 10 kids, right? And so birth rates start to go down when death rates are down, but there's a gap, okay? So there's a period of fast growth, but after a while, the birth rates kind of chillax a little bit, right? Birth rates go down and then, and death rates stay low. So populations still grow, but they don't grow as fast, okay? So this process of going from this time to this time to this time is called demographic transition, right? And different populations of people, different countries are in different stages of the demographic transition, right? So Italy is like here. Yeah, actually, they're probably closer to here. Okay, they're very slow growth, if any at all. Somebody just opened the door and is sneaking up behind me. It's a husband. I'm gonna have to pause. Popcorn out there. Ooh, thank you. I didn't pause my video. I paused my share because I don't know how to work my things here. So sorry you guys got to hear me talk to my husband about popcorn. I'm just glad he was wearing clothes. Okay, back to demographic transition. No, thank you. Back to demographic transition. I don't need them calling the dean and being like, there was this naked guy, it was terrible. I also don't want to redo my video either. Okay, where were we? We were talking about demographic transition. Okay, so Italy's like there. The US is like here, right? Ethiopia and Kenya, from those examples before, they're like here, right? Where they still have really high birth rates. Yes, human population growth is a part of biology. Get out of my office. Anyway, I can smell the popcorn. I'm gonna have to go now. Popcorn is my favorite. I don't know if I told you guys that, but it's in my bloodline to love popcorn. All Chamberlains love popcorn. I know you don't know I'm a Chamberlain because I took my husband's last name because I don't know why I did that. But anyway, yeah, but I'm a Chamberlain. Chamberlains love popcorn. Anyway, okay. So that's demographic transition, right? So some countries, some places in the world are still, they're not as far along in this process, right? The death rates are starting to go down, but the birth rates haven't caught up or slowed down with them yet. And so you have these areas where you have really high, really fast population growth, right? And it's different in different places, right? And a lot of it has to do with all kinds of other, all kinds of things that I'm not going to get into too much because this is not a sociology course, nor is it a history course, nor is it a economics course, nor is it any of those other things. So I'll let you learn about those in other places. Okay, so demographic transitions, what is that called? Overall though, overall human population growth, okay, is pretty amazing. So we've been talking about population growth these last couple of videos, and we've been talking about the difference between exponential growth and logistic growth, and we've been talking about what a carrying capacity is. And so one question that you might be asking yourself is, what is the carrying capacity for humans, right? What is the limit? How many humans can the Earth support, given our need for space and resources and all of that. And that's actually incredibly hard to calculate because technology is allowing us to utilize resources differently than we have in the past, right? So we expand into new habitats, right? We invented air conditioning, so now we can live in the desert, right? We build taller buildings that we can cram more people into. Right? We develop methods of agriculture that produce more food, per acre, right? We, all kinds of technology, right? That allows us to suck more resources. Yeah. So it's hard to estimate. Some people think that we're over our carrying capacity already. Other people think that we're nowhere close, right? And it really varies depending on how you make that estimation, right? Okay, so let's look at history a little bit. So this only goes up to 2000. So this is actually quite old, but there's one thing that I like about this little diagram. So we'll come back to that in a second. So what type of population growth do we see here in humans? Do we see exponential growth? Do we see logistic growth? What do we see? That is classic exponential growth, right? So real slow for most of human history. And then we hit that little divot. What the heck happened? What was that? That was the plague, right? The bubonic plague, the Black Death. What's sort of remarkable about that is, since it was such a long time ago, we don't have any kind of frame of reference for that, but at least a third of the population, more like 2/3 of the population died during the Black Plague. Okay. So, imagine, you live with 6 people and 3 or 4 of them die, right? Think about how it would affect communities, right? If 2/3 of the population just died, right? So actual real big divot, okay? Black Plague. And then what started happening around here, right? That's when we started getting real smart. And that's when we started getting smart. We were smart before, but this is when the Industrial Revolution happened, right? This is when advances in medicine happened. This is when advances in sanitation happened. This is when people discovered how you get sick, right? What are the causes of illness? Back in the bad old days, people thought that, you know, if you got sick, you were infected with bad humors. What is that even? That it doesn't even make sense, right? So, yeah. So, Industrial Revolution is when that is. Okay. And then from there, okay. I vividly remember, when I was a student at Chaffey in 1996 is when I started at Chaffey, and I left Chaffey at 99, right? So that's like, yeah, okay. And everybody was freaking out about how we were getting so close to 6 billion. And oh my God, can you believe there's 6 billion people on the earth? Well, where are we now? 2000. So ignore the bars, that's birth rate. We're just looking at total population. So we're looking at the line, okay? This starts much later. So, you know, the Industrial Revolution is shown, but the bubonic plague is off the chart. It's not on this chart because of the time scale is different, right? So this is 0. So our next one, the other graph, starts right there. It starts after the Black Death. And then this to here is all stretched out. Okay, so different scale. Okay, so we're looking at that line. Party time. Lots of population growth. Where are we now? We are here. Guess what we're close to now? Like I said, in 96, we were all like, oh my gosh, like we're right. We're so close to 6 billion. There's going to be so many people. It's terrifying. And now here we are. Not really that much time later. I mean, I'm old, but I'm not that old. Okay. 25 years later, right? And we're already looking at getting right up cozy with 8 billion. So we're like at 7.8 billion, I think, right now. Yeah. So it took, you know, all of human history to get to like 1 billion. And then, you know, it only took 100 years to get from less than 2 billion to get up to 6 billion. Right? So we're like, you know, population growth is through the roof right now. Okay. Now, this also shows birth rates. So you'll notice low, woo, higher demographic transition, yo, birth rates, we're going up like crazy, right? Not as many people, right? Not as many people are dying. So, lots and lots and lots and lots and lots and lots of babies, because people were like, no, man, that's what we do is have babies. Well, now people are starting to catch up and they're going like, whoa, I don't need this many. Right? So you'll notice that the bars are going down, right? And that's worldwide. That's not just any particular, you know, one particular country, right? So birth rates peaked in the 80s. Yeah. And they're starting to go down. The problem is though that even though birth rates are slowing, human population is continuing to increase because we're still, you know, we have a long lifespan, right? And because of the way in which, you know, people that are born now aren't producing until, you know, 20 years from now, right? So that's, you know, so that's where we are, right? And that, ooh, whoa, my lighting changes a lot when a lot of my face is lit from the computer. I have terrible lighting. I need to get one of those little like ring lights for selfies. Anyway, so that's the end of this. Okay, so next week we're going to start community ecology. We're going to be talking about all kinds of community topics. We're going to be talking about things like predation and things like parasites and all kinds of interesting relationships between different organisms. And then after that, we're going to talk about the effects of human population growth. So for now, we're just looking at human populations and how they grow and how they've grown. Later, we'll talk about the significance of that. Okay, so that is it for population ecology and, you know, our intro to ecology. Okay, all right, see you guys in the next one.